In our previous lesson, we added support for updating resources inside of our RESTful API using the put HTTP method. In this lesson, we're going to discuss how to partially update resources using the patch HTTP method and the JSON patch document. So what is JSON patch? It's a data format for specifying updates that should be applied to our resources. A JSON patch document consists of a set of operations, and there are a few possible operations that you could execute. We have the add operation for introducing a new property on a resource, the remove operation for removing a property from a resource, then we have replace and move that deal with exchanging values, and then there are the copy and test operations. The copy operation provides us to copy the value to a given destination, and the test operation should return a success status code if the values at a given path are equal. Now this is a bit abstract, so let's take a look at a practical example. This is what a JSON patch document could look like, and you can see it's an array of operations. Each element in this array contains a couple of properties. First, we have which operation we are performing. In this case, we are doing a replacement in both examples. The path for performing an operation should match the property name on our DTO or the resource. In this case, we are targeting the name and the description paths. And then we have the value that we want to set in place of whatever is currently present in the name or the description paths. So this is how you can apply a partial update using the JSON patch document. Now let's move into the code and I will show you how to implement this. We'll have to start by installing a few additional NuGet packages. I will right-click my DevHabit API project and I'm going to look for JSON patch. And the NuGet package that you want to install is Microsoft ASP.NET Core JSON patch. This introduces support for working with the JSON patch document, so let's go ahead and install that. But one more thing that we will need is serializer support for the JSON patch format. And this is available from the Microsoft ASP.NET Core MVC Newtonsoft JSON library, which includes input and output formatters for JSON and JSON patch. So let's go ahead and install that one. And then let me show you how to set this up. We have to add support for Newtonsoft JSON serializers by chaining a call to add Newtonsoft JSON after we configure our controllers. This is going to switch out the system text JSON serializer, which is the default serializer in ASP.NET Core, with the one from Newtonsoft JSON. So now we are using a different JSON serialization library to return our API responses. I'm still including the XML serializers to support content negotiation, but since we mainly focus on JSON, Newtonsoft JSON is what's going to be powering our API responses. Now let's go into the controller and see how to implement a patch endpoint. We have to start with the HTTP patch attribute. Because I want to apply this to a specific habit, I will specify the identifier in the route. I'll copy the above method up to the identifier, which is coming from the route, and let's change the name from update habit to patch habit. And then comes the JSON patch document, which we can reference because we installed the respective NuGet package. Now I have to specify a generic argument to the type of the resource that I will be applying my JSON patch document to. In this case, I'm going to use the habit DTO, which is the representation of my resource. You can also use the habit entity, but this brings us back to the concern about coupling the internal and the external facing contracts. So let's call this the patch document. And then what should we have inside of the request body? So let's copy what we already had in the put endpoint. We will first fetch the habit from the database, return 404 not found if it doesn't exist, and then we have to proceed with the partial update. Now notice that the JSON patch document is using our habit DTO, which means I need to get a DTO instance. Luckily, I can do this relatively simply. All I have to do is access my entity and call the toDTO method. And then I can go ahead and apply my patch document by saying patch document apply to and specifying my habit DTO instance. There's also an extension method that accepts a model state dictionary, which allows you to perform some validation afterwards, and if the model state isn't valid, you can return a bad request. Instead of a bad request, you may also consider returning a validation problem, which is going to return a problem details response and convert the model state dictionary into a set of errors. Now let's say we get past the validation step we need to map the changes back from the habit DTO into my habit entity. Now, in order to not make this overly complicated, I will only support patch updates to the name and the description property. So I'm going to say habit name is equal to habit DTO name, and then habit description will be equal to habit DTO description. I also have to consider updating the updated at property, and let's set it to datetime UTC now. And now I can go ahead and say database context, save changes async, and we can return 204 no content. We can do much more with a JSON batch document than what I just showed you here. It also allows you to manipulate any nested resources inside your representation. For example, from the habit DTO, we could manipulate just the frequency or just the target or just the milestone, but this is going to become pretty cumbersome inside of our implementation, so I just want to simplify this example. Let's go ahead and run this and see if it's working. First, I will fetch the current state of my resource by sending a GET request with the correct resource identifier. And this is the response that we get back. So here's our current state of the habit. And now let's try to do a patch update. I'll head over to my patch request, which is targeting my base URL /habits/the identifier. I'm specifying the same identifier as the habit that I want to update. And then here is my JSON patch document. I have two replace operations. The paths are name and description, and I'm specifying the values that I want to update inside of my resource. So if I send this request, I will land on the breakpoint inside of my patch endpoint, and I'll fetch the habit from the database. Then we're going to map the habit into my DTO, and once I have my DTO, I can apply the JSON patch document. If I expand the patch document instance, you can see I have two operations defined, which are the two replace operations that I have. And now let's go ahead and apply them from the patch document onto the habit DTO. Take a look at the name on the DTO, which is daily coding here, and then the new description of the habit, which is the current value of the description. So once I execute the apply to step, and we observe the description and the name, you can see that I now have the new values. The model state is valid, so now I can proceed to map the updated values onto my habit instance, persist these changes in the database, and return a 204 no content response. So now if I retrieve the habit again, you will see that it has been updated, and also the updated at time has been adjusted to the latest time we changed this resource. Now what will happen if I send a slightly different JSON patch request? Let's say I omit the name operation, and instead of using a replace, I use a remove on the description path. I don't need to specify a value, and then let's go ahead and send this request. We're going to land on our breakpoint, fetch the habit, map it to a DTO, and then let's observe the description, which contains the latest value from the habit entity. Now I'm going to apply my patch document, and if we take a look at the habit DTO, you can see that the description has been set to null. The model state also says that this is valid, so we can proceed to update our habit entity, save the changes in the database, and return a 204 no content response. If I fetch the habit again, you will see that the description has now been updated to a null value. Now let's try removing the name using our JSON patch document, and let's send another request. We're going to fetch the habit again, map it to a DTO, and apply the JSON patch document. The name of our habit is now null, but if we take a look at the model state, you can see that it still says that this is valid, even though we don't explicitly support setting a null name. So we need to implement some more robust validation for this to work in order to implement updates using the JSON patch approach. If I were to replace this with a call to try validate model, and I pass in my habit DTO, and rerun the application. And then let's try sending the same JSON patch request to remove a name from our habit. And now take a look at what's going to happen. We're going to return our habit from the database, map it to a DTO, apply the JSON patch document to the DTO instance, and when we try validating, we're going to run into a validation error. So we're going to return a validation problem, and if we go back to Postman, you can see that we are getting back a 400 bad request, saying that the name field is required. So this gives us some level of protection from performing operations that aren't allowed on our resource. Now, what if I specify a path that doesn't exist on my resource and send the same request again? Let's say this time I want to replace this with a given value, and let's just specify some dummy value of 1 to 3. Let me send this request, and we're going to land on this breakpoint. We will fetch the habit, map it to a DTO, try to apply the JSON patch document, and we're going to run into a validation problem. So let's return this, and this time we're going to get a different validation error saying that the target location specified by the path segment was not found. So using this validation approach together with JSON patch protects us from updating non-existent fields on our resource. So if I go back to a proper replace and I specify that I want to replace the name path with just the value of daily coding and send this request, and let's say I let the endpoint continue to completion, we should get back a 204 no content response. And if I go ahead and fetch the resource, you can see that my name is now properly set. So this is how we can implement support for partial updates using the JSON patch document. Another option that you could consider if you want to implement some sort of partial updates is, let's say, instead of using JSON patch, you define a specific path where you can apply the partial update. Let's say I want to archive my habit. I could define an endpoint like this, where I'm specifying a habit with a specific identifier. Then I have another segment in my URI, which is called archive. Now the problem is, this is a verb, and this isn't how we should define proper REST APIs. However, if we were to approach this with a dose of pragmatism, this will help us implement a more pragmatic API that might be easier to use for our API clients. I'm going to discuss this in more depth in a future lesson, but I just wanted to give you something to think about when it comes to being strictly RESTful and implementing the most correct support for each HTTP method, and then also considering when to break the rules and introduce something that makes your API more usable, but may not be completely compliant with RESTful principles. If we wanted to support partial updates of even more properties, then we just have to define the mappings back from the habit DTO into the habit entity. We could do this similarly to how I did it over here by defining an extension method for updating my entity from a DTO instance. So we could wrap this code that I have here into a helper method. But at this point, you should ask yourself, is implementing support for the patch HTTP method something that your API really requires? In practice, support for the patch method isn't too widely used, and most REST APIs fall back to just using the put method for doing partial updates. Now, when it comes to what you want to support inside of your APIs, you should carefully weigh the pros and cons of supporting a complicated operation like patch with the JSON patch document, and also consider what are the implications of integrating with an endpoint like this from your API client. Your client will have to know how to structure a JSON patch document and be able to send it to your API in order to apply the partial update. Whereas with an HTTP put endpoint, it might be simpler to send a representation of the resource and apply only the updates that you need. And another third option to consider is having some specific patch endpoints that only update a subset of the properties of your resource. So far, we have implemented support for getting a resource from a REST API, creating a resource, performing an update using put, and a partial update using the patch HTTP method. And in the next lesson, we're going to complete the so-called CRUD methods by implementing support for deleting resources using the delete HTTP method.